Let's continue talking about ratios, and in this case we're going to expand what our knowledge about ratios by talking about proportions. And so here's what a proportion is. A proportion is an equation that states that one ratio is equal to another ratio. So if you remember in the previous video we talked about equivalent ratios, right? This is a different way of setting it up so that we can use an equation and use some properties of proportions to try to figure out missing quantities if we need to. Right? So a proportion is just an equation that says one ratio or one fraction is equal to another ratio. Right? So if you notice 2/3 is equal to 4/6, and I know this because if I were to take this and say times 2, I get a 4. If I do this times 2, I get a 6, and that's what we said equivalent fractions and equivalent ratios. That's how we did that. So this is a true proportion where we're comparing 2/3 and 4/6. We're saying that they're equal to each other. Okay? So here's an important fact about proportions. If you cross-multiply equivalent fractions, you will always get the same value when you cross-multiply. So here's what that looks like. Okay, so we said just a second ago 2/3 and 4/6 were the same. I proved that to you by doing times 2 times 2. But here's what cross-multiplying says. If I take a numerator from one side and a denominator from the other, so for example, this 4 and this 3, okay, and I multiply them together, cross-multiplying, I get a 12. Okay? If I multiply the other two, this fact is saying I should also get a 12. And if you notice, 2 times 6 is also equal to 12. Okay? And so that's the idea of cross-multiplying. Here's a kind of a different one that I'll show you just for the sake of it. Everybody knows that 1/2 is equal to, for example, like, I don't know, 7/14. Right? These two are equal. When I cross-multiply this way, 2 times 7 is 14. 1 times 14 is 14, right? Any equivalent fractions, when you multiply a numerator with the opposite denominator, both ways, you will always get the same number, right? So we're going to use this fact. If we didn't know, for example, let me get rid of my stray mark there. If we didn't know, for example, what this number was, okay, let's say this was blank and I had a big question mark here, and I'm like, what should go here so that this equal sign is true, so that these are actually equivalent? We'd be like, well, okay, this way says 2 times 7, and that's got to be 14. So I have to put a 14 here so that when I do 1 times 14, it'll also work out, right? So we're going to use this fact to solve for missing parts in a proportion. So let's take a look at an example. This is a little bit of algebra, but not that bad, okay? So if you don't know one of the parts of a proportion, you can use this cross-multiplying fact to figure out what it is. So let's start off with this. This one's saying 3 times something should equal 1 times 21. So I'm going to write this out. 3 times something. If we have a basic knowledge of algebra, 3 times x is just x. Okay. 1 times 21 is 21. And so we would know that 3 times 7 gives me 21, but with our algebra, remember, if we're multiplying times 3, I can divide by 3 to cancel it, and then I'll divide this by 3. Right? So x, in this case, has to be 7. So we're saying that if you want equivalent fractions, if we want this equal sign to actually be a true statement, this needs to be a 7. Right? And so now we found the missing part of those equivalent fractions. This proportion is true now. So 2/3 and 3/16. This one's not as obvious, right? So how do I turn a 3 into a 16? I'm not that sure. It's not a nice whole number. Right? It's like a little over 5, but we're not exactly sure. So let's do cross-multiplying. 3 times something, well, that would be 3x, is equal to 2 times 16. Well, 2 times 16 is 32. Okay? So now I'm going to divide by 3, and I'm going to divide by 3. Okay? So that means x is equal to 32 over 3. Let's come off and let's turn this into a decimal form. So we're going to say 3 goes into 32. Well, 3 goes into 3 once. Okay? 1 times 3 is 3. Okay? 3 goes into 2. Well, it doesn't. Okay? So I'm going to put a 0 here, and I'm going to bring my decimal down. Okay, 3 goes into 20 like 6 times, right? Because 6 times 3 gives me 18. Okay, and so what I'm going to end up getting, and to save us a little bit of time, I'm going to get a repeating 6 there. Okay, so what we're claiming here is that this needs to be 10.6 repeating. Okay, so if I'm saying, you know what, I don't want 3 of something, I really want 16 of something. If we want to keep this ratio of 2 to 3, we'd need 10.6 of the other thing. So this is really why proportions are helpful, because sometimes, yeah, we can look at this and say 3 turns into 21 by multiplying by 7, but when we get to this type of problem, it's not as straightforward. So I'd need 10.6 of something, and cross-multiplying helps us figure out what that is. Right? So let's keep going. Okay, so I can grade 30 tests in about 45 minutes. If I was saying that I wanted to grade for 3 hours, and I'm wondering how many I can grade, here's what I'm going to do. So I'm going to say my ratio is 30 tests for 45 minutes. So I'm going to say 30, 45. Okay, and so what I'm going to do, just to keep myself organized, is I'm going to put some labels out here. This represents tests, that's 30. This represents minutes. Okay, so this is really tests over minutes, 30 over 45. Here's why that's important. On the other side, they're saying, how many tests? Question mark, I don't know. So we usually use a variable to represent that. I'm going to put a big X there. The bottom represents minutes, right? This, I'm not going to put a 3 here because that would be 3 minutes. I'm talking about 3 hours here, so let me get rid of this, right? There's 60 minutes in an hour, and I have hours, so I'm going to say 60 times 3. All right, that's 180 minutes. Okay, 180 minutes. Okay, so now I need to figure out how many tests can I grade in 180 minutes. This is where cross multiplying comes in. So I'm going to say 45 times x. Well, that's 45x. Okay, 30 times 180. Well, so let's go off and do that off to the side. So here's a nice little trick if you're unsure about multiplying with large numbers. Instead of me doing 180 times 30, I'm going to kind of get rid of these zeros. And I'm just going to do 18 times 3. I'm going to say 3 times 8 is 24. 3 times 1 is 3, with 2 plus 2 is 5. And then these zeros that I just got rid of, I'm going to tack on to the end, right? So that's 5,400. So we don't actually have to include those zeros. We'll just tack them on at the end. So 5,400. Okay. So now I need to do division. I'm going to divide by 45. I'm going to divide by 45. Okay. So again, this is a slightly larger numbers, so it's going to be a little bit of work. So let's get rid of all of our work here. Give ourselves some space. Keep ourselves organized. So 45 into 5,400. Okay. So 45 goes into 54 one time. 1 times 45 is 45. And that looks like a 9 left over. Okay, so I'm going to do 0. 45 goes into 90 2 times. Okay. Oops. Let's fix that. Okay. 2 times 45 is 90, with nothing left over. And then I can bring down this extra 0 and say 45 goes into 0 0 times. So it looks like 5,400 divided by 45 is 120. So that means x is 120. Okay? So to answer their questions, how many tests can I grade in 3 hours? Well, the answer is I can grade 120 tests in 3 hours. Okay, so this is what we would use a ratio and a proportion for. Is we're saying, well, the average is 30 tests in 45 minutes, but I don't actually care right now about 45 minutes. I care about 180 minutes, and so I want to keep this ratio the same and figure out that I can actually grade about 120 tests. Okay, so let's take a look at one more equivalent ratio problem here. Okay, so the senior class has a ratio of male to female 3 to 2. Okay, and if I'm estimating the male population, if there are 141 girls, right? So this is a similar kind of problem. So this represents male, okay, and this represents female. Okay, I'm gonna rewrite this in a fraction form. So I'm gonna say, okay, the problem is male. My penmanship. Okay, so male over female. Okay, and so male was 3, female is 2. So I'm setting up a proportion to find the equivalent ratio. So in this case, they're telling me that 141 girls in the class. I'm going to make this 141. Okay, I don't know male. It says estimate the male population. So we're kind of saying I don't know what the male population is. That's why I'm going to put an x there. Okay, now I'm just going to solve the proportion. 2 times x is 2x. 3 times 141. Okay. 3 times 1 is 3. 3 times 4 is 12. Right, 423. So now I just need to do my division. Okay, so 2 divided by 2 on both sides. Okay, and I'm going to say 2 into 423. Okay, so this goes in once. I'm sorry, let's fix that. It goes in twice. Okay, and then I'm going to bring this down and say 0, 2. 2 goes into 2 once. With 2, oops, let me scroll down a little bit. Okay, and again, this is a 0. I'm going to bring down the 3. 2 goes into 3 once, with 1 left over. Okay, and again, I'm not going to worry about the decimals because we're talking about male people here, right? So we're going to say X is about 211, right? So if you want to see our notation for that, we usually use this symbol. Okay, little squiggly lines here means approximately 211 people, right? So if we were to say that in an actual class there are 141 girls, we should expect there to be about 211, maybe 212, somewhere around there, 211 males. Okay. So again, this is the idea of using ratios and proportions: is we can scale up the small ratio of 3 to 2 and figure out that in this class it's actually 211 males and 141 females.